By the end of this video, you will know how to make your own game in Roblox Studio, and in today's tutorial, we'll be creating a simple obby that features lasers, moving lasers, spinning parts, moving parts, disappearing parts, along with checkpoints. Let's get into it. In our blank base plate, let's go ahead and create a part, and this will be our very first platform. Let's change the size of this part to 12 by 1 by 12. That's a perfect size. Let's use our move tool to move this part where we would like it. I want this part to be in the front of our spawn location. You can see this little widget on the top right. You can move your camera and you can see how it spins around. Well, this is how I know that I'm facing the front side, and I want my part to be on that front side. I'm going to make sure that in my model tab, my move studs are set to 0.5, but I'm going to make sure that I am lined up on this grid because each little square here represents one stud. So now I'm going to change my move increments to one stud, and now when I use my move tool, I can move along this grid and see exactly how far my spacing is. So I'm going to make our next platform about 8 studs away from our spawn location platform. So I said that's 8 studs because this is 1, 2, 3, 4, 5, 6, 7, 8 squares. Next, in my workspace, I'm going to create a folder by typing in folder, pressing enter, and then I'm going to rename this folder by selecting the folder and pressing F2, and I'm going to rename it to platforms, and I'm going to put this new part that we made in there by left clicking it and clicking and dragging it into that platforms folder. And so now this part that we created should be inside of a platforms folder now that's inside of the workspace. Select our part in the workspace. I'm pressing Control D on the keyboard to duplicate the part, and I want to make our second platform. So Control D duplicates the part. Now you can see there's 2 parts in the Explorer, and when I move, now you can see I'm moving a duplicate part. If your part didn't show up the same as mine and it showed up kind of above, that's because in your model settings, you want to make sure that your collisions and your join surfaces are turned off. So we've created our second platform. Let's create another platform by duplicating that, and now we have 3 platforms, and then let's make the 4th platform a checkpoint. So now we have 4 platforms, and our last platform, we want it to be a checkpoint. In our workspace, let's create another folder and let's rename it to checkpoints, and then we'll drag that last part into our folder, and now we have a folder called checkpoints and a folder called platform, all with different parts in them. So that way we know that this is a checkpoint. Why don't we color this part a different color, something like that kind of baby blue there, and then let's make sure all of our parts are anchored. So I'm gonna left click this part, and I'm gonna hold down shift on my keyboard and select another part, and then click another part and click another part, and then I haven't let go of shift yet. So now I'll go ahead and let go, and now I can click anchor, and now all those parts are anchored that I've selected. If we didn't anchor those parts, they would just fall and flop around because they're free. But when we anchor them, we say, hey, stay in this one single position the entire time. Okay, so let's check out our obby. I'm going back to the home tab, and I'm clicking this play button. Now the game loads up, and great, we have our first platforms of our obby. Of course, we have a blank base plate that's on here, and we'll get rid of that using code. So we have 3 platforms that we need to jump across, and then we have a checkpoint that we need to function. Next, let's create more platforms. And so I'll be clicking this platform, pressing Control D. Let's create another 3 platforms, and then let's create another checkpoint. So I'm going to click our checkpoint part, and then I'm going to Control D to duplicate that. And so now we have 2 checkpoints. Next, let's create another folder in our workspace, and let's call that folder lasers. And next to the lasers folder, let's click the plus sign, and let's type in part, and then let's select part. Let's select that part in our Explorer, go on over to the properties, scroll down to the bottom, and on our shape property, let's go ahead and change that to cylinder. And then let's change the size of that cylinder to 12 by 1 by 1. And then let's make the color of the cylinder red and the material of the cylinder neon. And now let's get this positioned on top of our platform. So just use your move tool to position it on top of your platform. And there we go. Now we have a laser on this platform. So I'm going to put this laser on our second platform actually. And there we go. We've got our first laser that has to function the way we need it to. And then on this next platform here, let's press Control D on our keyboard. We've duplicated a laser, and let's move it on over to our first platform after our first checkpoint. And then let's rotate this laser 90 degrees. And then let's move this laser to the left side of the platform. We want this laser to be a moving laser that moves from the left to the right and then back again, and then cycles over and over. Let's go back to our laser that's going to be stationary. This laser is not going to move, but let's select it, and then let's press Ctrl D to duplicate that laser, and then go back to our moving laser, press Ctrl D to duplicate that, and we'll put that on the next platform. Next, let's duplicate 3 more platforms. I'm going to click on my base plate to deselect everything. I'm going to hold down Shift on my keyboard, and I'm going to select these 3 platforms by left clicking on them and holding down Shift. And now, just to make sure, in my Explorer, I only have 3 parts highlighted. I'm going to press Ctrl D on my keyboard, and that is going to create another 3 platforms for me. And I'm going to space those out there. And then I'll click on this checkpoint, Ctrl D, and create another one. And now we have our last checkpoint there. So we have 3 checkpoints in total. And for these platforms, I want them to do various things. I want this first platform to move back and forth. I want this second platform to disappear and reappear again. And then we'll also make this platform move back and forth as well. Now in our Explorer, click the Platforms folder, click the plus sign, type in part, select part, and this new part that just showed up, go ahead and select it, and go scroll to the bottom of the properties, and let's change that part to a cylinder. And then let's change the size of the cylinder to 48 by 12 by 12. Press enter, and then let's rotate the cylinder 90 degrees using our rotate tool, and then let's use our move tool to move it back in place. And then I see the color is a light blue here. Let's go ahead and make that back to the default gray. Let's move this cylinder to our next jump after this last checkpoint, and then let's move the cylinder downwards so that way it's level with the rest of our playing field, because what we're going to do is make this cylinder spin clockwise, so that way we just have another obstacle. And then press Ctrl D to duplicate that part that's going to spin, and we'll place another one. So we'll have this part spinning clockwise and then this part spinning counterclockwise, and then we'll create our last checkpoint. And so this is the extent of the functionality of our obby. Let's get it working, and then I'll show you creative ways that we can make this obby challenging for players. In our Explorer, select the workspace, press the plus sign, and type in part, and then select part. And what we want to do with this part is use our move tool to drag it just under, somewhere low, because this is where when our players fall down, they're going to touch this part and get teleported back to their checkpoint or to the original spawn location. So use your scale tool to make this part, pretty big. We can make it as wide as the obby, as wide as a player is going to fall off. So I'm going to zoom way out over here in Studio, and then I'm going to use my scale tool to just drag this all the way throughout. And then we could go right back down. I'm using the scroll wheel on my mouse to move quickly in and out, to zoom in and out, and I'm using WASD on my keyboard to move around the screen. So I've added this part, and it's going to be the part that is the teleporter. So when a player falls down, they don't just die and fall through the world. They'll actually just be teleported quickly, and it just makes for a smooth obby user experience. Let's rename this part to teleport part. Okay, and with that done, let's start adding some object values to our lasers and our platforms. Starting with our lasers, we're going to add 4 object values. First will be a number value that we rename to move delay. So capital M, capital D, move delay. Next, we're going to add a vector 3 value, and we're going to name that to move direction. Next, we're going to add a number value. We're going to rename that to move duration. And then after that, we're going to add a Boolean value, and we're going to rename that to moving. Those are our 4 object values for our laser. Now let's go over the defaults of these object values. So the default number for our move delay is going to be 0.5. Default number for our move direction is going to be 12, 0, 0. Default number for our move duration is going to be 2. Default value for our moving is going to be false. So this laser, we want to be stationary, so we're setting the moving value to false. Now let's select our move delay and hold down Shift and select moving. And now you can see I've selected all 4 of those object values. Pressed Control C on the keyboard. Now you can left click the next part, then Shift and left click the next part in the lasers folder. So So that means you want to select the 3 remaining parts here because we have 4 lasers in total. On one laser, we've put in our object values, and on the 3 remaining lasers, they don't have the object values. So what we do is we select all of them by left clicking the first part and then shift left clicking the last part, and it selects all of them on the list. And then on the keyboard, I press Control, Shift, and V. And then as you can see, it's placed all of those object values into all of my lasers. So this laser here is going to be stationary, but these other 2 lasers are going to be moving lasers. So what we want to do is select our moving laser and make sure that our moving value is set to true. And then let's select our other moving laser and let's make sure that moving value is set to true. So that means that the checkbox is ticked. So the way I have this set up with the default values, with the move delay, every half a second, we cycle through an animation, and the move direction is this laser is going to move 12 studs to the right and then come on back. The move duration is how fast or how slow this laser is going to move back and forth. And then the moving value is whether this laser is moving or not. Next, we need to add our object values for every single platform. So let's go ahead and close our lasers folder. And then in our platforms folder, let's go ahead and choose the first part. And we're going to be adding 10 object values to every platform. Our first object value is going to be a number value, and we're going to rename that to disappear delay. Our next value is going to be a bool value. We're going to rename that to disappear. Our next value is going to be a number value, which we're going to call move delay. Our next value will be a vector 3 value, which we're going to call move direction. Our next value is a number value, which we're going to call move duration. Our next value is a bool value, which we're going to call moving. Our next value is a number value, which we're going to call spin delay. Keep in mind all of the lowercase and uppercases on here because if you misspell it, your code will error. Next, we're going to add a vector 3 value that we're going to call spin direction. Next, we're going to add a number value and call it spin duration. And last, we're going to add a Boolean value and we're going to call that spinning. Now let's go over all of the default values. The default value for disappear delay will be 3. Default value for disappear will be false, so the checkbox should be off. Default value for move delay is 0.5. Our default value for our move direction is 24,0,0. Default value for move duration is 2. Our default value for moving is false. Our default value for spin delay is 0. Our default value for spin direction is 360,0,0. Our default value for spin duration is 10. And our default value for spinning is false. Now, let's select all of these object values again. Press Ctrl C on the keyboard. And then let's select all the remaining platforms and press Ctrl Shift V on the keyboard. And now they all have those same object values. Now let's go through these platforms and specify which ones should be moving, spinning, disappearing, or whatever. So we know all of these platforms are going to remain stationary. This platform is going to be a moving platform. So let's select it and then take a look at it in our Explorer. So we see our part is selected here. And then let's go to the moving value and let's set that to true. And I've already got the default values for the move direction of this platform to move 24 studs to the right and come right on back. This next platform after the moving platform is going to be a disappearing platform. So let's select that, go to our Explorer, let's go to our disappear Boolean value and let's set that to true. And by default, this platform will disappear every 3 seconds and you can fall through the world. So you got to time this right. And then this next platform, let's select it and we're going to make this a moving platform. So let's make the value for that true. And then we have our last 2 platforms here, which are our spinning platforms. So let's go ahead and select our first spinning platform. Let's go to our Explorer and let's set the spinning value to true. And then I have the spin direction to be rotating clockwise already. And so we want the other platform to rotate counterclockwise. So let's select that one. Let's make sure that our spinning value is set to true. And then let's go to the spin direction. Let's turn that 360 into a negative 360. And so now this part should spin in the opposite direction. And then we have our checkpoint. I believe that's about all we need as far as building in our Explorer to get started with coding. Great, so now that that's done, let's go ahead and collapse everything in our workspace, close that all down, and then let's go to our server script service, click the plus sign, and type in script, and let's add a script. A script tab pops up. Now you see hello world. We can go ahead and clear that out. and we can start with our code. So first, let's skip a few lines because we're going to reserve the top of this for adding various Roblox services. Don't worry about it. You can have as much space as you want in your scripts. Your code will still function like normal. So when we first play our game, we spawn in and the base plate is still here. We don't want this base plate here. So that's going to be one of our first things we do. Let's go ahead and create a function and we'll call it initial steps, and then open and close parentheses. And in that function, we're going to go ahead and get the base plate by creating a base plate variable. And we'll get that base plate by saying, hey, game.workspace, which is this workspace folder, .baseplate, which gets the base plate, which is inside of the workspace, which this workspace is inside of the game. So that's why we say game.workspace.baseplate, and we've made a variable called that so we can call that easily. And the next line we'll type is baseplate destroy. And then at the end of our script, we'll go ahead and call our function by typing in initial steps, open and close parentheses. And when we start up our game, this function will run. So we call initial steps runs, we get the base plate, and we tell the base plate, hey, time to get destroyed, and our base plate will disappear. So let's click play and see if that works. Great, our base plate is gone, but I noticed our teleport part is not down there and is most likely not anchored. So let's fix that. And let's continue coding. All right, so go in our Explorer, open up your workspace, click on teleport part, and yeah, I can already tell that's not anchored. So go ahead and click the anchor button to anchor that. Next, let's go back to our script. Let's skip some lines after destroying the base plate, and let's get our teleport part because that's the next thing we want to get working. So we'll say teleport part equals game.workspace.teleport part. So what we're saying is we're going to game, go into the workspace and get that teleport part, and then let's take that teleport part and let's set the can collide property equal to false so that way players can fall through it. Let's set the teleport part transparency to half so that way it's kind of semi-transparent. And then let's say that if this part is ever touched, then we'll fire a function that will teleport the player back to their original spawn location. The .touched event always passes the part that is touched, so I always call that parameter part touched. And then we'll get the part's parent. So we'll create a variable called part parent and we'll make it equal to part touched.parent. We're going to create a variable called humanoid, and we're going to say if part parent has a child within itself called humanoid, then return that humanoid, or if it doesn't, then return nil. Next, we're going to do the same thing for the humanoid root part. And so I just type in root part after this, and this is what we're going to use to teleport the player. And then next we're going to get the player, but first we're going to need a service. So up at the top of the script, we're going to type in a variable called players, and we're going to make that equal to game::get_service, open close parentheses, quotations, players. And so this is our player service. This is what we're going to use in our initial steps function. So we're going to make a variable called player, and we're going to make that equal to our players service. And we're going to use a service called get player from character, and we're going to put in the part parent because that is what the character theoretically is. That's what we're checking for. And then we're going to have a conditional statement that says, hey, if a player exists and a humanoid root part exists and the humanoid exists and the humanoid.health is greater than 0, in other words, if the humanoid's not dead, then let's teleport that player, create a variable called spawn cframe, and we're going to make that equal to the current spawn location's cframe. And then we're going to teleport that player by setting the player's humanoid root parts C-frame equal to the spawn C-frame. But I want the player to teleport slightly higher than the C-frame, so let's create another variable above that called height offset, and we'll make that equal to a new vector 3 value that's 0, 10, 0, and then we'll add the height offset to spawn C-frame as the final teleport location for our player. So let's press Control S on the keyboard, and you go ahead and save your game to Roblox. You can title it whatever you want, add the description, and then save if the little window pops up for you. Let's go back to our game and click play. So now our base plate is gone, and you can see that we have our teleport part down there. So now if I fall through, I get teleported back to our spawn location. So anytime I mess up a jump, like oops, now I get teleported back. Instead of having like a really long fall animation and then waiting 3 seconds to kind of respawn. Speaking of player respawn time, at the very top of our initial steps function, let's make some space. Call that players service and let's say players.respawn time equals a half a second. So that way when a player oofs, they come back almost immediately. Next, I noticed something going on with these moving parts. So make sure to select your spinning parts and make sure that they're anchored. I guess we forgot to anchor these spinning parts. Back to our script, let's create some room in between our calling of initial steps function. And in between that, let's create another function that we will call initiate lasers. That's what will start up our lasers to moving and to damaging our player. So in our Explorer, let's make sure that our folders are collapsed here. Let's uncollapse our lasers, and then let's go ahead and collapse all of these. So now we can easily see our lasers. And in our initiate lasers function, let's go ahead and call the lasers folder by creating a lasers variable. And we'll say game.workspace.lasers. That's what calls the lasers folder. And then what we're going to say is :get children. And this is a method that's going to get every single child in that laser folder, which is our 4 lasers, these 4 parts. Below that, let's create a for loop that goes through the entire folder, gets those lasers, and then by getting those lasers, it will allow us access to change some of the properties. So let's go ahead and insert our lasers next to the pairs here. And so what this for loop says is for every single laser in pairs in our lasers folder, do. And what we want to do is get the properties of that laser, and mostly the object values that we put inside of each laser. So first, let's go ahead and get the moving property by creating a moving variable and making it equal to laser.moving.value, and then we'll say or false. So what this is saying is loop through our lasers folder, get every single child, and for every single child, look and see if there is a moving object value. And if there isn't a moving object value, then just set this to false. But if there is a moving object value, we're just going to read it and it's either going to be true or false there. So remember, some of our lasers have this value set to true because they're a moving laser. Next, let's get the move delay, which will be equal to laser.moveDelay.value, and then we'll say or 0.5. See, those are the default values that we were mentioning earlier. Next, we'll get the move duration, which is equal to the laser.moveDuration.value, and then we'll get the move direction, and this one's a vector 3. Default value is 12, 0, 0. So now that we've got our 4 properties, on our next line, we're going to set the lasers can collide property to false, so that way you can actually walk through the laser. We're going to run the lasers.touched event if a player actually touches the laser. We know that the touched event passes the part touched. The same as above, we're going to get the part's parent by calling part touched.parent. We're just going to check if this is a humanoid by saying part parent find first child and checking for the humanoid, and we're going to say if the humanoid exists, and that's spelled wrong, and we're going to say if the humanoid exists, then set the humanoid's health to 0. So we've got our moving laser properties. We set our can collide property to false. We said if the laser touches a player and that player has a humanoid, then set that humanoid's health to 0. Below that, let's set up the moving laser itself. So if our moving value is equal to true, and remember moving's up here, this is our variable. If our moving laser.moving.value is equal to true, then we want this laser to move. So we're going to create a few variables for our tween service, which we're going to need our easing style, which is enum.easingstyle.sign, and then we're going to need an easing direction. We're going to make that equal to enum.easingDirection.out. We're going to need a repeat count. We're going to set that to -1, so that way the loop cycles repeatedly. We're going to need a reverses Boolean value, which we're going to set to true because that means it will cycle repeatedly. Also, this means that the laser will come back and then the repeat count will be -1 and it loops over and over again. And then back up at the top of our script, below our players, we want our tween service. We're going to create a variable called tween service, and we're going to make it equal to game get service quotation tween service. And then back down below our reverses value, we're going to create another variable called tween info. We're going to make that equal to tweeninfo.new, open and close parentheses, and within that parentheses we're going to add the following values. We're going to add our move duration, we're going to add a comma and press enter. We're going to add our easing style, comma enter, our easing direction, comma enter, our repeat count, comma enter, our reverses Boolean value, comma enter, and the move delay. And then below that parentheses, we close out the tween info. We're going to create a variable called new position, and we're going to make that equal to the laser's current position plus our move direction value. Then we're going to create another variable called tween tab, which is basically the property that we want to alter. So the property that we want to tween is our position, and we want that position to equal our new position. And then below that, we're going to create a new local variable called tween, and this is where we're going to call our tween service. We're going to create that tween, and we're going to open and close parentheses. Inside the parentheses, we're going to add the following values. We're going to say that you're going to tween the laser, and we want you to use this tween info that we stated earlier, along with this tween tab that we stated earlier. So our tween info is, how fast does this laser move, different settings, does it repeat, does it reverse, and then do we delay our movement? That's all the tween info. And then the tween tab says, hey, what we're tweening is the position from the laser's position to the new position. And then we're going to actually call this tween and tell it to play. And then last but not least, we're going to call our function. So let's go ahead and copy and paste our initiate lasers, and then below initial steps, we'll paste our initiate lasers there. So now what we're saying is how this script runs is it runs from the top to the bottom. So it loads up these services. It sees these functions, but they're closed off. We haven't called them yet. And then we call our initial steps function, which sets the player's respawn time to half a second, destroys the base plate, gives functionality to our teleport part. And then we call the initiate lasers function, which gets all the lasers from our folder, gives them functionality, makes them move. And now we'll click play and see if that works. Great. I can see our lasers are moving very funny, and I already know why. It's because we forgot to anchor them. So let's go back to our game and let's make sure that all of our lasers are selected and that they are anchored. Always anchor your parts. So let's go ahead and run through this obby and let's make sure that everything is working. There goes our moving lasers. Great. And you have to avoid them. So we've got our first obstacle. Now, if I walk through this laser, I should get oofed. Perfect. Got oofed, got teleported back. So we know that our stationary lasers work perfectly. Now let's go check if our moving lasers work perfectly as well. So let's go ahead and let this get us. Boom. Great. We know that that works. The next thing we want to do is go back to our script and let's go to our initial steps function. And let's skip a few lines after we've gave functionality to our teleport part. And below that, we'll call our players service and say that every time a player is added, let's connect this function. And what we want to happen is we want to create a variable called checkpoint. We're going to make that equal to a new instance called object value. And this is how we're going to add the checkpoint functionality to our obby. So let's make the checkpoint name equal to checkpoint, and let's make the checkpoint value equal to nil. And then let's set that checkpoint's parent to the player. And every time a player is added, when this function is connected, the player is passed as a parameter to this function. And so that's how we get the player. Let's skip a couple of lines after that. So what we've just said is we're going to create an object value. We're going to name it checkpoint. We're going to set that value to nil, and we're going to parent it to our player. Next, we want to say when our player's character gets added to the game, let's connect this function. So every time our player dies and reloads, our character gets added and this event gets fired and this function should run. Every time our player's added to the game as brand new, we're listening to the character added, we run the function. So on here, let's add a wait statement. That just gives some time for the player to load in. I just added as a little safety mechanism. You don't want to use this often, but it's working in this simple obby game. Next, let's create a variable called player checkpoint, and we're going to make that equal to player find first child, and we're going to be looking for that checkpoint value that we created earlier. Let's create a height offset because I know we're going to be teleporting a player. I always like to teleport a player about 10 studs higher than they need to be, just so it looks like they fall into place. Next, let's create a spawn C-frame variable, and we'll set that equal to the current spawn location for right now. And then we're going to say if the player checkpoint exists and the player's checkpoint is not equal to nil, and that the player checkpoint dot values type is equal to instance. And there's our conditional. We check if the player checkpoint exists, and we check if it's not nil, and then we check just to make sure that the value value type is an instance. We just avoid many errors that way. It's better to be safe than sorry. So if those cases are true, then we're going to make the spawn C-frame equal to the player checkpoint dot values C-frame. What's going to happen is we're going to have our various checkpoints set this checkpoint object value to its physical part. And that's how we're going to know where to teleport this player. Next, let's get the character and say wait for child. And we want their humanoid root part. And we're going to teleport that humanoid root part by setting the C-frame of the humanoid root part to the spawn C-frame plus the height offset. And you can see this character is underlined because every time the character added event fires and we connect the function, the character is passed as a parameter, and that's how we get the character. Next, in between our initiate lasers and our initial call functions, let's go ahead and make some space, and let's create another function called initiate checkpoint. And so if we look at our Explorer, we have 4 different checkpoints. So we're going to call our checkpoints folder by saying that our checkpoints folder is at game.workspace.checkpoints, and we're going to get the children of that folder. We're going to loop through that checkpoints folder. We're going to use a for loop to loop through that checkpoints folder. And for every checkpoint, we want to create a detector part. We're going to create a new part instance, and we're going to set that detector part's anchored property to true. We're going to set the detector part size to the checkpoint size plus an additional 12 studs. We're going to set the detector part's position to the checkpoint's position, and then we're going to offset it to just above the checkpoint by adding a vector 3 value that has a y value of the detector parts dot size dot y value divided by 2, 0. Then we're going to set the detector parts can collide property to false. We're going to set the detector parts transparency to 0.5. We're going to set the detector parts parent to game.workspace.checkpoints, which is the checkpoints folder. And then we're going to say if this detector part is touched, then let's run this function. And as usual, we get the part touched, and we're going to get the parts parent, making the part touch.parent. We're going to get the humanoid by checking the part parent and seeing if it has a humanoid part object in it. And then we're going to get the player by using our player service, using the get player from character method and including our part parent in there. And then we're going to say if the player exists and that player has a humanoid and the humanoid is not dead, then we're going to check if that player has a checkpoint by finding the first child checkpoint. And if the player checkpoint exists, then we're going to set that player's checkpoint value to that current checkpoint. And then we'll want to call our function after the lasers. And in order to get our checkpoints to work, we need to be able to teleport to that checkpoint. And so now we need to add this checkpoint functionality to our teleport part as well. So what we're going to do is we're going to go ahead and just copy and paste from our character added and just replace these 3 lines here. And so now we're going to check for the player checkpoints. If our teleport part is touched, we're going to check if the player has a checkpoint. If our player has a checkpoint, then let's set the spawn C frames to that checkpoint's location. And then over here, we already get the humanoid root part, so we can replace this character wait for child humanoid root part with just humanoid root part. Press save. But wait, before we click play, I just realized that like all of my height offsets are misspelled. So here's an easy way to fix that. Just go ahead and double click your misspelled word, press Control F, and then click that little drop down menu there, and I'll copy this height offset and replace it with the real spelling. So right now I have it as hey offset when it should be height offset, and then I'll just go ahead and click this replace all button, and now it's all spelled correctly. So I'm going to save this and play. Great. And it looks like we've got all of our checkpoints. So let's go ahead and go for it. And I'm going to make it to the first checkpoint here. Great. Now I'm here. And so let's go ahead and like oof. And then I should respawn at the checkpoint. Good. And I don't respawn back at the beginning. And also if I fall on our teleport part, I respawn to the checkpoint. So let's go ahead and check the next one. See if that works out. Great. And now we're at our moving platforms and our disappearing platforms that are supposed to do their thing. And then we are at our cylinders, which are also supposed to spin. Let's see if I respawn back there. Perfect. I'm right next to the cylinders. So let's get all the rest of these platforms working by creating our initiate platform function. So in between our initiate checkpoints and our opening initiate calls, we're going to create some room. We're going to create a new function called initiate platforms, open close parentheses. This is going to be our longest and most complex function. So just do your best to follow along with me. The first thing we're going to do is get the platforms by going to the platforms folder, and then we're going to get all the children of that platform. We're going to run a for loop that goes through all those platforms, so that way we can change their properties. Next, we're going to create a variable called current platform, and we're going to make that equal to platform. And we're going to be altering this variable later, so that way we can make our parts spin and move. Next, we want to get all of the platform values, which there's over 10 of them. So we're going to be listing them now. So we're going to create a variable called moving. That's going to be equal to platform, find first child, quotation mark moving, dot value, or false. Another variable called moving duration equal to platform, find first child, moving duration, dot value, or 2. There's so many of them to type up. I'm going to type them up now, and then you could pause the video and copy them. All right, so here's our 10 values. We got moving, moving duration, move direction, move delay, spinning, spin delay, spin duration, spin direction, disappearing, and disappear delay. Then we're going to say if moving equals true, then we know that this is a moving platform, and we want to make that platform move. So let's create a function inside of here called playTween. And in there, we need to create an easing style, and we'll do enum.easingstyle.sign. We need to create an easing direction, and this will be out. Our repeat count will be -1. Our reverses value will be true. Let's create our new tween info object. In there, we'll put the moving duration, but I noticed I called it moving duration. I want to call that move duration. And then back up here, I have it called moving duration. Let's go ahead and change that to move duration so they match. So I'm going to put the move duration, comma, enter, the easing style, and then the easing direction, and then the repeat count, reverses, and last but not least, the move delay. Then we're going to put in our new position. This is just like the lasers, very similar to the lasers, except we're just moving the platform. And so we're going to set this to our move direction, and then we're going to need our tween tab, which is also similar to the lasers because we'll be changing the position property of our platform to the new position, and then we want to create the tween that's going to actually play. So we use our tween service to create, and then we're going to be moving the platform. We'll be providing the tween info along with the tween tab, and then we'll tell this tween to play. And then at the end of that, we need to call our function. And then, so let me show you guys what happens if we just kind of run our system like this. And then I forgot to put at the end of all of these dot value. So at the end of all these parentheses, we need to say dot value. So after we've added the values, let's go ahead and run our function after our initiate checkpoints. And let's see if this works. I got an error, attempt to index nil with value. And that's because I have this moving duration misspelled. It should be move duration, not moving duration. So I'll save and play. Okay, so now we've got our platforms working. And so let me show you guys what happens if we just leave it like this. So as you can see, the platforms are moving, but when we jump on the platform, our character does not move with it. We kind of have to run with the platform, and if we stay still, the platform just leaves without us. So we have to do something special here, and I'm going to teach you how to do that today, so that way you can have moving platforms that will move with your character, and you don't have to run with them. In order to maneuver our way around that problem, we need to create another function in between initiate platforms and initiate checkpoints, and we'll call that function create moving parts. And what this is going to do is it's going to create a new part, make it the same size and shape as our platform here. It will create a couple of attachments, create an align orientation and an align position object that will allow our new platform to carry our characters by using this align orientation and align position object. So just follow along on the script here. In our create moving parts, we want to pass a parameter that's platform, and then we want to run this function before we play the tween. So what we want to do is we want to say that our current platform is going to equal our create moving platforms, and we're going to pass our platform as a parameter. So what we're saying is when we run our initiate platforms function, we go through the platforms folder, and for every single platform, if the moving value is true, let's move that platform back and forth, and let's run the create moving parts function. And when we run the create moving parts function, we get the platform as a parameter, and we want the platform's transparency property to equal 1. We want the can collide to equal false, so that way it can move through our new part. We want to create a new attachment, and we're going to call that attachment 1 and make that equal to a new attachment instance. So we spawn a new attachment, we make that attachment's parent equal to the platform, and then we're going to give that attachment a name and call it attachment 1. Next, we're going to create a new part called solid part, and this is the part that our player is actually going to stand on and will actually be able to move with that part. So the part carrying our player rather than our player trying to keep up with it. So we're going to create the solid part, and we're going to make the part's shape equal to the platform shape. So basically we just need this part to match the dimensions and properties of our platform. So we're going to give this solid part a name and call it solid moving part. We're going to make sure that our anchored property is false. We're going to set the size to the platform size, and we're going to set the position of our new part to the platform's position. And then we're going to create another attachment, but we're going to call this attachment 0. Using the same instance.new, we'll be spawning in a new attachment, and the attachment 0's parent will be the solid part, and we're going to change the name of the attachment to attachment 0. Next, we're going to create an object called align orientation, which will work to keep our part's orientation, or pretty much like rotation position, aligned with our platform. So we're going to parent this to our platform. We're going to make the align orientations attachment 0 equal to attachment 0, and then we're going to make the align orientations attachment 1 property equal to attachment 1. So that's why we named those like so. And then we want the rigidity enabled property set to true. And then we want to do the same thing again. So I'm going to copy and paste this, but we're going to call it align position. And so instead of align orientation, we're going to create align positions. And so make sure that these are all align position, and make sure that this is set to align position. And we're going to use all the same properties there. So we need both an align orientation object and an align position object. And then after we create those objects and we've parented them, we're going to finally parent our solid part to the platforms folder. And then we're going to set the solid part's network ownership to nil, which will make the server own that part, and then it'll move smoothly for other players. And then at the very end of that, we want to return our solid part. So we run our create moving parts function, it returns the solid part at the very end of it, and our current platform is now equal to this new solid part. So now when we click play and test this and run all the way up to our moving platforms, which I wish I had moved those platforms much closer than I have intended, because I have to play my obby over and over again. Granted, let's see if our platform now moves our character. So that's why we went through that whole mess, just so that our character can stand on this moving platform and it'll work. Next, we're going to work on our spinning cylinders over there, and last, our disappearing platform. So now in our initiate platforms function, we'll skip a few lines after if moving, and we're going to say if spinning equals true, then it's very similar to if the platform is moving. So what I'm going to do is I'm going to copy and paste this and put it into spinning. And then we're going to change a few things here. So we're going to change sign to linear. We're going to change out to in. We're going to change reverses to false. We're going to change move duration to spin duration. We're going to change move delay to spin delay. We're going to change move direction to spin direction. And we're going to change this position to orientation. And I'm going to copy and paste this. I'm going to change this variable to new orientation. And you can see this new position got underlined. So I'm going to change this new position to new orientation. And I'm going to change this position here to orientation. And so now if we Control S to save, go play and see if this works. So my spinning parts are way too far away. I don't want to do my obby to get there. So just press Shift plus P on the keyboard. And now you can move around just like you're in the the workspace. And now we can inspect if our cylinders are indeed turning, and they are. Check it out. We've got our spinning parts going. Next, we want our disappearing platform going. So let's get that finished. So below our if spinning is true, we'll create another conditional statement and say if disappearing equals true, then that means we want our platform to disappear. So within this, let's create a function called update platform. And within that function, let's create two variables, one called skip, and we'll set that to false. We'll create another variable called inc up, and we'll set that to false. So this is a skip variable, and this inc up variable means increment up. Next, we're going to use run service. So let's go back up to the top of our script, and let's call our run service from Roblox. So we'll do game get service, run service. This is what we need. Let's go back down to our disappearing, and we'll run service dot heartbeat connect this function. And within this function, we'll say if skip equals false, then we'll have another variable called original value, and we'll set that equal to false. And then we'll say if inc up equals true, then original value equals true. And then below that conditional statement, we'll say if our current platform's transparency is greater than 1, then we want our increment up value to be false, and then we want the current platform's transparency to be subtracted from by 0.01. Then we'll do an else if conditional statement, and we'll say if our current platform transparency is less than 0, then we're going to set our increment up to true, and our current platform's transparency to add 0.01 to itself. And then we'll have another conditional that says if the current platform transparency is equal to 1, then we'll say the same thing as inc up false and start subtracting. And then we'll have another else if statement that says if the current platform's transparency is 0, then we're going to increment up everything. So if increment up is true, the transparency gets added to. If the increment up is false, then the transparency gets subtracted from. And then we'll have our another else if conditional that says if the current platform's transparency is less than 1 and our current platform's transparency is greater than 0, then if our inc up value equals true, then we're going to make our current platform's can collide property equal to false. So that means that the player will fall through. And then we're going to increment up the transparency by 0.01. Otherwise, if the inc up is false, then we're going to make sure that our platform's can collide value is true, meaning that the player can stand on the platform. And then we're going to make the current platform's transparency increment downwards by 0.01. And so this is extremely messy. If you know how to do this better than I, please leave a comment down below. I'm looking for a solution. After this, we're going to say if our original value does not equal our inc up value, then if our increment up value is set to true, then we're going to set our skip equal to true. And then we're going to say task.delay, parentheses. Our first value is going to be our disappearing delay, comma, and then we're going to put a function. And within that function, we're going to put a for loop that repeats itself 3 times. So we're going to say for count equals 1, 3 do. And within that, we'll wait a half a second, and we'll make the current platform's transparency equal to 0.5, and then we'll do another wait for a half a second, and we'll make the platform's current transparency equal to 0. And so what this is going to do is going to make the platform blink 3 times. We're going to wait another second, and we're going to set that skip back to false. And what this is going to do is it's going to make the platform blink before it actually disappears. So that way a player gets a warning before they know they're going to fall through that platform. If our inc up is true, then we'll do that. But if our inc up is actually false, then what we're going to say is that our skip is equal to true, and then we'll set a task delay of 1 second, add a function there, and then we'll set the skip back to false. And what this does is it says if the inc up value is equal to false, then stay invisible for 1 second. And just before the very end of our if disappearing equals true conditional statement, and in order to find the end of it, we just go ahead and collapse that, and we see we have this end here. Then go ahead and decollapse it, and you'll see we still have that end highlighted. So just below that, what we'll say is task.spawn, and we'll run the update platform function. So this creates a new thread and runs the update platform function, which runs a heartbeat, and this heartbeat pretty much controls whether our platform is reappearing or disappearing again. We have different delays. We stay appeared for 3 seconds, and then we blink before we disappear. And then when we disappear, we stay invisible for 1 second. And then we set the skip back to false and we run this function all over again. So let's go ahead and Control S to save this and run our obby to see if everything works. Great, so we've got our first platforms. Let's make sure our laser does oof us. Let's make sure that our teleport pad does teleport us. That works. Good, so we're doing some thorough testing of our obby. We've ran into our first checkpoint, so when I die here, I should respawn back to that checkpoint. Perfect, and if I jump off the platform here, I should teleport back to the checkpoint. So we know checkpoints are indeed working. Now let's make sure that our moving parts are actually working, and it looks like they are. And also our disappearing part is not doing what it's supposed to. Okay, I found my mistake. This wait 1 second and this skip equals false. We need to have that within our task.delay. So let's add it in there and then delete the original. And now our platform should work as expected. Perfect. So we've got our moving platform. So when we jump on them, it moves with us. And then we've got our disappearing platform that will blink before it disappears. So that's our warning that's going to disappear. And then it fades and disappears. We can no longer jump on it, but it comes back and now it's solid again. And then our platform will begin blinking again. That means we got to get off. And now we jump on our next moving platform, jump to our next checkpoint. And so now if we fall off here, we should just respawn back over there. Perfect. And now we can go to our moving platforms and hopefully not fall off. And they move in opposite directions here. And then we make it to our last checkpoint. And I believe now everything is functional and we are ready to build out our entire obby to make it more difficult. So I've made the obby a bit longer, a bit more difficult. We have our initial platforms, our moving lasers, we have moving platforms, a disappearing platform, more checkpoints, spinning platforms, and then we turn right over here. We've got a spinning platform plus a moving laser. We've got another checkpoint. We've got a moving platform plus a laser, another moving platform plus a laser, another moving platform plus a laser. We've got another checkpoint, and then we've got a disappearing platform. We've got a spinning platform plus a long laser. We've got another disappearing platform and a moving platform plus a laser, and then our last checkpoint. So let's play this and find out if it works, and I'll teach you guys how to make adjustments because I know some of this is going to be messed up. Let's see what it looks like. All right, so now I have shift to sprint added. That comes from my shift to sprint tutorial found on YouTube. I'll link it in the description below, but it gets added to the starter player and then the starter character scripts. Here's what that script looks like. All right, let's do this obby. So now I get to sprint slightly. Awesome. Get to run a little bit faster and we get to avoid these lasers. Let's do this. Okay, pretty fun so far, pretty challenging. And I know that platform's about to disappear on me. Yep, it's blinking. It's about to disappear. Let's keep going. Good. We've got the spinning parts and they're spinning in opposite directions. Pretty easy. Awesome. Okay, this looks to be working correctly, but this laser does not move all the way across the length of this cylinder. So we'll have to adjust that setting. And then let's head on over here. And now we've got these platforms moving all correctly. Oh man, that is pretty challenging. There is a stationary laser here, which now you have to jump over and you have to time your jumps perfectly now. And then at the very last part, we've got a spinning part with a moving laser. Oh gosh. Okay, so I forgot that platform disappeared. I forgot those platforms disappeared, but we're okay now. And oh yeah, we're good. I am the obby master. And of course, if we fall down here, we don't have the teleport part down there. So yeah, that's just going to waste the player's time. Let's see, we make it back because we won the entire obby. So let's make a few adjustments and make everything work. I'm going to teach you guys kind of how to alter the properties of these object values that we've added. So remember that this laser did not span the length of this cylinder here. So what we need to do is we need to go into that laser's move direction vector, and we want to make that move direction equal to 48 studs because that's how wide this cylinder is. It's 48 studs. So now this laser will move 48 studs that direction and be good to go. And then for these moving parts, how I made it opposite to each other is this moving parts move direction setting is at -24, and then this move parts move direction is +24. So they move opposite to each other. Next, we have like a disappearing platform, but on top of that, we can make this a disappearing platform and it moves at the same time. So as a matter of fact, let's go over here back to the beginning. Here's a disappearing platform. We have the disappear value to true, but if we set the moving value to true as well, that means this platform will be a moving platform and a disappearing platform at the same time. So let's go ahead and just move this platform back over here, and then you'll see that it'll be disappearing and moving at the same time. Another trick I'd like to add over here is to this laser in the beginning. Let's go ahead and alter the properties of this laser, and let's make the moving equal to true, and let's make the move direction, instead of the X value equaling 12, make the X value equal 0, and make the Y value equal to 12 instead. And now we'll press Control S. And last but not least, let's make this teleport part much bigger. So let's just scale it way out to here. And there we go. And so now if we fall down, we'll just teleport right back. And it's just my preference to keep this base plate, but you guys could just go ahead and just delete it just as easily as well. But I personally like to see the grid, and then I just delete it when the game starts. So let's press Control S and save and see how this plays out. So now if we take a look, we've got our laser moving up and down now. So you can make these lasers move in any direction that you want simply by just changing the direction values. And then over here, we've added the moving value to our disappearing platform. So now our platform disappears and it moves at the same time. And then back over here, we have the laser spanning the entirety of our spinning part. So this is how you guys can create an extremely fun obby for you and your friends and see how far you can get. Of course, all of the code is going to be available. You can download this world, play it for yourself, and hopefully I taught you today how to make your own game, how to make a simple obby. Press the like button if you found this video valuable.